Alright, I hope you had a chance to try this one. So a little bit harder than the last one, and the main reason it's harder is because in this case, remember, we always need to put things in standard form first, which means that it equal to 0. In these two examples, a doesn't equal 1. Okay, so let's first start by putting this in standard form. We'll move the 3v over. So we have 4v squared plus 8v plus 3, and that's equal to 0. Okay, again, this is not going to factor. Even if we try to use the swing method here, it's not going to work, so we'll move that number over here. And then here's the key part of this problem. Completing the square only works when this number here is 1. And if it's not 1, we need to make it 1. How can you make it 1? Well, v squared is being multiplied by 4, so we can cancel that out by dividing by 4. And I have to do that all along this problem. I can't just divide one term by 4. I have to keep the equation balanced by doing it to everything. So 4 divided by 4 is that, v squared. 8v divided by 4 is 2v. And then this is a fraction, negative 3/4. Okay, we left a space there so that we can have enough room to complete the square. So we need to take half of that middle number. Half of, in this case, 2 would be 1. And then we'll take that number and we will square it and add it right here. And then we're going to add it over here too. But remember, if I'm adding 1, 1 as a fraction is like 1 over 1, and I need it to have a common denominator with 4. So that means I need to multiply the top and bottom by 4. So 1 is the same thing as 4 over 4. Okay, this is now a perfect square. That's going to factor to v plus 1 squared. Once again, where did the 1 come from? It came from half of that number. And then negative 3/4 plus 4/4 is 1/4 right there. Okay, how can we solve that? Well, we need to get rid of the squared term by doing the opposite, which is square rooting. And then we'll square root this side. Now, square rooting a fraction is the same thing as square rooting the top and the bottom. And then let's remember to put the plus or minus in front. So these will cancel. We're just left with v plus 1 equals plus or minus. Square root of 1 is 1, and the square root of 4 is 2. So 1/2 is the square root of 1/4. Very last step is we need to subtract this 1 over, and then we have negative 1 plus 1/2, and that's equal to negative 1/2. And then we also have negative 1 minus 1/2, and that's equal to negative 1 1/2 or negative 3/2. So in this case, it would be good to simplify it out to these two terms and not just leave it like this, because we could simplify it further. It's always a good idea to simplify as much as you possibly can. All right, last one right here. We'll put this in standard form as well. Let me just clear those off. All right, so first of all, let's put this in standard form. We need it to equal 0, and the easiest way to do that would be to move these two things over, like you see us doing right now. And then we'll subtract this 6 right here. So 2p squared plus 6p squared, that's 8p squared, minus 16p, and then 50 minus 6 is the same as 44. That's now equal to 0. Okay, this is not going to factor, so let's move the 44 over. And by the way, you could, in theory, you could have just moved it over right here, but I'm just showing you to make sure you're not going to be confused by that. So 8p squared minus 16p equals negative 44. Now here's the key thing. Remember, this number has to be 1, and because it's not 1, we need to make it 1. That means we have to divide everything here by 8. So we'll have p squared, 16 divided by 8 is 2p. And then this right here simplifies. 4 goes into that twice, and 4 goes into 44 11 times. So that's the same thing as negative 11 over 2. Now we're in a position to complete the square. So we can do that by taking half of the middle number, half of the b term. Half of this number is negative 1. We'll square that to get positive 1. And then over here I have to add a positive 1 too, but I need positive 1 with a denominator of 2. And that's the same as 2 over 2. 2 over 2 is the same as 1. And remember, I'm adding 1 to both sides. So just to note, this right here is 1. This is a perfect square that factors to p minus 1. Where did minus 1 come from? Came from half of that. And then negative 11 over 2 plus 2 over 2 is negative 9 over 2. Now we can finish this problem, so we need to get rid of this squared by square rooting. And whatever I do to one side, I have to do also to the other. Put a plus or minus in front right there. So those will cancel. We'll have p minus 1 equals, okay, so the bottom is still going to be the square root of 2. The square root of 9 on top, the square root of 9 is 3. The square root of negative 9 is not 3, it's going to be 3i. And hopefully you might remember that from earlier in this unit when we were talking about imaginary numbers. Okay, there's two more things to do. So we haven't talked so much about this. We will in a future unit, but we haven't talked so much about this. Normally, it's discouraged to have things on the bottom with square roots in them. So the way that we can fix that is whatever square root you're taking, multiply this fraction by that same square root on the top and the bottom. Why would you do that? Well, there's two reasons. First of all, square root of 2 times square root of 2, that's the same as the square root of 4, or that's the same as the square root of 2, the whole thing squared. So what happens if you square root something and then you square it? Those basically cancel each other out, and you're just left with positive 2. So if, for example, if this right here, if this had been the square root of 11, you would multiply over here by the square root of 11. If that had been square root of a trillion, you would do times square root of a trillion. The reason we do that is just so that we have this number here with no square root against it, because this is equivalent to square root of 2, the whole thing squared, and that's how we cancel out the root. Why do we have to do the same thing on the top and the bottom? Because what does this equal? If you look at it, square root of 2 divided by itself, that's another way of saying 1. And the question I have for you is, what happens if you multiply something by 1? And the answer is nothing happens. It doesn't change the value. So that's why we're allowed to do that, and that's why we have to do that. So this top is going to become 3i square root of 2 over 2. So let's just clean this up a little bit. So we have p minus 1 equals plus or minus 3i square root of 2 over 2. Very last step here is let's add the 1, so that goes away, and we add it over here, and there's our final answer. So that's how you complete the square. It's a pretty important topic. It's used in a lot of problems in algebra, pre-calculus, even in calculus you use it. And so hopefully it makes sense. If not, go back over some of these videos, watch them again, and see if you can solve those problems.